After training and evaluating our machine learning model, it is important to understand some common pitfalls that frequently occur in machine learning projects. Two of the most common problems are overfitting and underfitting. Let us first discuss overfitting. Now, overfitting occurs when a machine learning model becomes too specialized to the training data. Instead of learning the general patterns in the data, the model essentially memorizes the training examples. This means the model performs extremely well on the training dataset but performs poorly when applied to the new unseen data. For example, imagine fitting a highly complex curve through every data point in the training dataset. The curve may perfectly match the training data, but when new data points appear, the predictions become inaccurate. This situation often occurs when the model is too complex, the dataset is too small, or the model is trained for too long. Now let us consider underfitting. Underfitting occurs when a model is too simple to capture the underlying structure of the data. For example, suppose the relationship between two variables is curved, but the model uses only a straight line to represent the relationship. The model will fail to capture the real pattern. As a result, the model performs poorly on both training data and new data. In practice, successful machine learning requires finding a balance between model simplicity and complexity. A good model should capture the general pattern of the data without memorizing noise or random variations. If a machine learning model does not perform well, there are several strategies that can be used to improve its performance. One of the most effective ways is to simply collect more data. Machine learning models typically perform better when trained on larger datasets because they can learn more representative patterns. For example, a model trained on only 100 images may struggle to recognize objects accurately, while a model trained on 100k images can learn much more robust features. Now, however, collecting additional data is not always possible. In such cases, another powerful strategy is feature engineering. Feature engineering involves improving the input variables used by the model. For example, instead of using raw data directly, we may create new variables that better represent the underlying relationships. In a housing price prediction model, instead of using house size and price separately, we might create features such as price per square meter or neighborhood average price or distance from city center. These engineered features may provide stronger signals to the model. Another approach to improve performance is to try different algorithms. Different models capture patterns in different ways. For example, linear regression assumes linear relationships. Decision trees capture hierarchical patterns, and neural networks capture complex nonlinear relationships. Experimenting with different models often leads to better performance. Therefore, improving machine learning performance typically involves a combination of better data, better features, and better models. Machine learning projects often involve complex workflows that include data processing, feature engineering, model training, and evaluation. Because of this complexity, documentation becomes extremely important. One of the simplest but most valuable forms of documentation is code comments. Code comments explain what each section of the code is doing and why certain decisions were made. Without comments, code may become difficult for others or even the original author to understand later. For example, a comment might explain why a certain preprocessing technique was applied or why a particular hyperparameter value was chosen. Another important form of documentation is the README file. A README file provides an overview of the project, including the purpose of the project, the dataset used, installation instructions, how to run the code, and expected outputs. In collaborative environments, documentation ensures that team members can understand and reproduce each other's work. Good documentation also helps when sharing projects publicly on platforms such as GitHub. Ultimately, proper documentation improves collaboration, maintainability, reproducibility of machine learning experiments. While machine learning provides powerful capabilities, it also raises important ethical considerations. One of the most significant concerns is bias in machine learning models. Bias can occur when the training data does not represent the real world population fairly. For example, if a facial recognition system is trained mostly on images from a specific demographic group, the model may perform poorly when recognizing faces from other groups. Similarly, biased datasets in hiring systems could unintentionally favor certain applicants over others. Therefore, developers must carefully examine datasets to ensure fairness and inclusivity. Another important ethical issue is transparency. Many advanced machine learning models, particularly deep neural networks, function as black boxes. This means their decision making processes are difficult to interpret. In sensitive applications such as healthcare, finance, or criminal justice, transparency is crucial so that decisions can be explained and justified. A third major ethical concern is privacy. Machine learning models often rely on large amounts of personal data. Examples include medical records, financial transactions, or social media activity. Protecting this data is essential. Techniques such as data anonymization, secure data storage, and privacy preserving machine learning are used to ensure that personal information is protected. Ethical machine learning development therefore requires careful attention to fairness, accountability, transparency, and privacy protection. Machine learning is a rapidly evolving field and mastering it requires continuous learning. Fortunately, there are many excellent resources available for further study. One category of resources is online courses. Platforms such as Coursera, edX, Udacity, etc. offer courses taught by leading researchers and industry experts. These courses often include video lectures, programming assignments, and real world projects. Another important resource is books. Many foundational machine learning concepts are explained in textbooks that provide deeper theoretical insights. Now, examples include books on statistical learning, deep learning, or pattern recognition. Finally, research articles and technical blogs are also some valuable resources of up to date information. Machine learning advances rapidly, and new techniques are frequently introduced through academic publications. Reading research papers helps learners stay informed about the latest developments in the field. Combining courses, books, and research articles allows learners to build both theoretical knowledge and practical skills. Let us conclude by summarizing the key ideas from this session. First, we learned the definition of machine learning. Machine learning is the field of enabling computers to learn patterns from data and make predictions without explicit programming. Second, we explored the machine learning pipeline. Building a machine learning system involves multiple stages, including data collection, data preprocessing, feature engineering, model selection, model training, model evaluation, and model deployment. Each step contributes to building reliable and effective predictive models. Third, we discussed the three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Each type addresses different kinds of problems and uses different learning strategies. Finally, we saw how machine learning is applied in many industries such as healthcare, finance, transportation, and entertainment. Machine learning continues to transform technology and society, creating new opportunities for innovation and discovery. Understanding these foundations prepares us to explore more advanced machine learning techniques in the future. Thank you for your attention, and I look forward to continuing this exciting journey into machine learning together.